All right, this is for chapter 16, video assignment number 1. Okay, so in part A, it tells us to write the balanced reaction of the metabolization of glucose. Here we have on part A, 1 mole of glucose, 6 moles of oxygen gas, 6 moles of CO2, 6 moles of H2O. That's the balanced reaction. Okay, now part B, calculate the delta G, or Gibbs energy for the reaction in part A. Given that the delta G formation for glucose is negative 917.2 kilojoules per mole. So looking up all the rest of the values in OpenStax to be able to find the values to be able to find the delta G of the reaction products minus reactants. There we are. Okay, but the important thing is we need to include the moles involved in this reaction, or the coefficients. We need to include those in this products minus reactions. For example, here we have all the delta G of formation of all of these products and reactants for this. So here we have the first one, CO2, and there's 6 moles of it, so 6 times that plus 6 times H2O, there's 6 as the coefficient for both of those, minus negative 917.2 is the glucose, and there's only 1 mole of it, and then O2 is going to be 0, so we don't need to include that. That comes out to be negative 2,871.56 kilojoules per mole. Okay, now we're on to part C, where it asks us to find the work that Gibbs energy liberated by the metabolization of glucose is providing the energy to lift the bird. The work the bird is doing is working against gravity. That is, and then it gives the equation right there. So basically just plugging and chugging. We have the bird mass, which is given to us, is 30 grams, put into 0.03 kilograms. That's what that is. And then we have 9.8 meters per second squared is what we have as the gravity, right? And then we have the height and change in height in meters, which is 10, which is given to us in the problem. So that turns out to be 2.94 joules, and with all of joules is also equal to all of those different units, which are included in this problem. So that's part C. Part D, it gives us, using our answer from part B, to determine how many moles of glucose are needed to complete the action in part C, given that metabolization provides the energy per mole as given in B. So we can do that by taking the answer from part B, which is the delta G of the reaction, put that in joules, so which is 2,871,560 joules per mole, and times that by 2.94 joules, which is what we found in part C. How much is needed for that reaction, or that action? Multiply that together, and we find that 1.024 times 10 to the negative 6 moles of glucose are needed for that part. And that is parts A, B, C, and D for problem number 1 for video 1 on chapter 16.